Hello children, welcome back. Now I am doing 9th class, second chapter, that is polynomials and factorization. So before going to that, let us have a discussion about proverb. The proverb is, try and try till you win. Means what, children? Usually it's a habit of every individual that they thought that I should do this and they start working upon it. While doing itself, they may find that something is not possible, something he needs to get it which is not there, or they may feel that they may feel very lazy to do it. Because of that, what happens, children? They'll stop that work. They won't continue it. That is a very wrong practice, children. One should always have a determination that I have to do it, and whatever hurdles comes in the way, don't neglect or don't just go after them and having a lot of thought that I cannot do it, I cannot continue it. Stopping it in between is not the thing, children. You need to continuously think about a solution for the problem that you have got, and definitely your mind will give you the solution. When you are thinking, you are sharpening your mind, you are making it activated, so definitely you will be getting the solution. So when once it is wrong or once you have failed, don't stop it, children. Continue your efforts till you get the success. That is only the way in which you will be successful in your life. Let us come back to our topic. The topic is polynomials and factorization. Children, when you are doing in your lower classes, you have done about algebraic expressions. So let us first talk about what is meant by algebraic expressions. What are algebraic expressions? Algebraic expression means it is an expression which is made of a constant term and a variable with different operations between them. What do you mean by that? Between them. What do you mean by that operations? Like addition, subtraction, multiplication, and division. So when you have got a constant term and a variable, so these two words meaning you should know, children. Constant term. What is constant term? Constant term means any number. Any number. A number cannot be changed. If you say 6, that will be 6 all the time when you are solving that particular problem. In that problem, whatever is the number that is given, that is constant term, because it cannot be changed. We call it as a constant term. Then what is meant by variable? Variable means ever changing. That is called variable. Ever changing means these are all letters. All variables are letters. So if you take x as a letter, usually in algebra unknown factor is considered as x. If you take it as x value can be 1, x value can be 2, x value can be any other number. Why, children? Because it's a variable. Means according to the value of this variable, the total algebraic expression value will change. Say for example, if I take 3x, in case if I take x is equal to 1, then 3 into 1 is equal to 3. If I take x is equal to 2, 3 into 2 is equal to 6. So what is happening, children? 3 is constant and these numbers are variables. This variable, x is variable. Actually this number, of course, this is a number, no, so why you said it is a constant, but you are now saying variable. Means I said it as variable because it is the value given to the variable. I have given to the variable x as 1, so I have taken 1. Here to the variable I have given 2, so I have taken 2. So whatever the variable value you are taking and you are doing the operation, what you are getting is a different answer. So an algebraic expression which is made up of constant term and a variable with different operations between them. What are the operations means? Addition, subtraction, multiplication and division. So as examples, what you can take, children? You can take, as I have taken here, 3x, 4 plus x, 5 minus q, 7 by r. Anything you can take. These all can be taken as examples of this algebraic expression. Please copy it, children. Now, after knowing what is the meaning of algebraic expression, now we are going to deal with our topic, that is polynomials. So what is this polynomial, children? Now we will talk about polynomials. So the polynomials, it's again an algebraic expression. Polynomial is nothing else. It is also an algebraic expression. That is why, to know the definition of a polynomial, you should know what is algebraic expression. That is why I have explained you what is algebraic expression. So polynomial is an algebraic expression. It is an algebraic expression in which the variable has non-negative powers. This is a polynomial. Non-negative powers means what, children? Positive powers. Positive powers. It is an algebraic expression in which the variable has non-negative powers. Example, 2x square plus 3x plus 4. This is called as a polynomial in which power of the x is positive. See, suppose if x has got a power negative, what can you write, children? It has 1 by x square. The reciprocal you have to write. So whenever the denominator is having variable, you will not call it as a polynomial. It is not a polynomial. So you should understand this, children. Whenever a term, an algebraic expression is given to you and they ask you to say whether it is a polynomial or not, you just observe the denominators. If you have variable in the denominator, definitely it is not a polynomial. Why? Because if variable is in the denominator, when you are taking that variable to the numerator, you are giving a negative sign. But what is the definition of the polynomial saying? The definition of the polynomial is saying that it is an algebraic expression in which the variables will have non-negative powers, that is positive powers. So all algebraic expressions, all polynomials will have powers as only positive but not negative. So this is the definition of algebraic expression, children. Right on. Polynomials definition. Now, let us go for the next topic. Now, you have polynomials in one variable. Polynomials in one variable. What is this means? A polynomial which has only one variable is a polynomial with one variable. Example: 3x 4x cube plus 2x square plus 1, 7p to the power of 5 plus 6p cube plus p square plus 1, suppose. These all are considered as polynomials with only one variable. One variable means what, children? Only x here for this polynomial. Here also x. Here p. So, total expression that is given to you contains only one single letter. That is called as polynomial with one variable. Okay, children? Right up. Now, the next one, in page 29, you have got certain do these problems. What are they? The first one, write two polynomials. You have to write two polynomials with variable x. So what can you write, children? 2x cube you can write, 7x to the power of 5 you can write, plus 2x square plus 4. Anything you can write. A polynomial with variable x. Single term also is considered as polynomial. Now, the second bit, three polynomials with variable y. So, 2y plus 5, 7y square plus 3y plus 4, so on. 3 he said, no? Next. 8y cube plus 7y square plus 6y plus 3. Anything you can write, children. So this is 1, this is 2, this is 3. These all are the polynomials. You can even have minus here, children. It is not compulsory that you should have plus. You can even write minus also, no problem. So these are the polynomials with variable y. Next is what is that they have given? 2x square plus 3xy plus y square. Is it a polynomial with one variable, they are asking? No, it is not, because variables are x and y. You are having two variables. You have x as well as y. So you cannot consider it as variable 1. Next, write the formula formula of area and volume of different shapes and find out the variables and constant terms. That I require more space, children. If you copy this, I will do that in the next part. Now, they are asking about various shapes and you need to have areas, and afterwards they are asking about volume. Means you should know about the formula, children, and volume, and find out variables. What are variables written in that, and what are the constant terms. This is what you need to find out. So the shapes, you can take the first one. You take a cube, children. Cube. What is the shape of the cube? You have done in the earlier classes also. It will be having, usually if you talk about the shape of a cube, same length, same breadth, same height. This will be like this. If you draw cube, length, breadth and height will be same. This is a cube. So for this you have two areas. First one is lateral surface area and second one is total surface area. Lateral surface area can be written as 4a square, means 1, 2, 3, 4 sides it is having. So each one is a square. So square area is a square. So 4a squares. Total surface area is 6a square, because not only lateral, top and bottom also you have to take. Then what is the volume, children, here? Volume is a cube, length into breadth into height. All are a only. So a cube. So what is the variables you have written? You have got in this formula, you have only one variable. What are the constant terms you have? You have 4, you have 6. These are the two constant terms you are having here, children. Next, you are going to talk about cuboid. Cuboid shape is like this. It is a rectangle base. So length, breadth and height. This is also having lateral surface area and second one total surface area. So lateral surface area formula 2h into L plus B, and total surface area formula 2 into LB into BH, LB plus BH plus LH. This is the formula for total surface area, and volume is L into B into H. And what are the variables you are having? You are having L, B, H. And what is the constant term you are having, children? It is nothing but 2. So this is one more shape. And the next one we talk about the cone. Cone you know pretty well. This is the shape of the cone. And this cone will be having lateral or okay, you can write a curved surface area, and the second one total surface area. Curved surface area is pi or L, and total surface area is pi r into L plus r. This is the formula. So volume of this is 1 by 3 pi r square h. This is the volume, 1 by 3 pi r square h. So what are the variables you are having? You are having r, you are having L, you are having h. So the constant term you are using is 1 by 3. Next, after cone, the fourth one is sphere. What is sphere, children? Usually you will draw sphere like this, and sphere you will be having only one area, that is its curved surface area, and this is 4 pi r square, and its volume is 4 by 3 pi r cube. So the variable here is only r, and constant term is 4 you take as well as pi, because pi is 22 by 7. Next, cylinder. So how will you draw cylinder? This is cylinder. So the cylinder will be having curved surface area, and second one total surface area. So curved surface area of cylinder is 2 pi r h, and the total surface area is 2 pi r into h plus r. This is the formula, and its volume is pi r square h. So what are the variables you are having here, children? You are having r and you are having h. Only 2 are there as the variables. And what is the constant term you are having, children? You are having 2 here, and also you are having pi. So these are the various the formulae and shapes. What is the question? Write the formula of, I'll read the question for you. The question is, write the formula of area and volume of different solid shapes. Find out variables and constant terms in them. So different solid shapes, what we have done? We have done here cube, cuboid, cone, sphere and cylinder. These are the shapes, children. Now here for cube you have lateral surface area, total surface area. Formula I have given. In the formula, what is the variable, the formula of areas and formulas of volume you have to take. What is variable, what is constant term. So similarly for all cuboid, cone, sphere and cylinder, for all this is the case. What is the area, what is the volume, what are the variables you have taken, and what are the constant terms are there. So write down, children. Now we will see the next part. The next part is degree of a polynomial. What is degree of a polynomial? Degree of a polynomial. What is the meaning of this, children? Degree of a polynomial means the highest power of a given polynomial is called the degree of the given polynomial. As an example, we will take 2x cube plus x square plus 5. See, x is having 3 as power here, 2 as power here. So, what is the highest power? Highest power in this is 3. Therefore, degree is 3. Understood, children? Whatever is the given polynomial, in that what is the highest power that you take, that is called degree of the polynomial. Write down this, children. Write it down. Now, you have certain problems into this, children. Let us go through those problems. Page 30. Do this. In your textbook, page 30. The first one, you have to write the degree. They have given you the polynomials. You have to write the degree. The first one is 7x cube plus 5x square plus 2x minus 6. So, what is the degree here, children? See, x is having highest degree 3, no? So, 3 is the degree of this polynomial. Second one, 7 minus x plus 3x square. So, 2 is the degree of the polynomial. And third one is 5p minus root 3. Here, p has only variable is only 1p. And what is its power, children? You are not able to see any power. So, since you are not able to see any power, you should not take it as 0, children. Be careful. I have found many students taking without any power as 0. No. Any number to the power of 0 becomes 1, children. There will not be any expression of variable here if you have power 0. But in this case, you have the variable given. So, what is this variable, children? The variable with nothing power means it has a power 1. So, 1 is the degree. Next one, minus 5xy square. Now, see this problem. Here, you have got an expression with 2 variables. So, when you have an algebraic expression with 2 variables or a polynomial with 2 variables, when you are talking about the degree, you have to add the powers of 2 variables. Then only you will get a degree of that particular expression. Following, children? When it is only 1 variable, in that variable which is the highest power, that we will take. In case if the polynomial is given with 2 variables, in that case, that 2 variables means the 2 variables are taken as a single term. In that case, what is its degree means? You have to add the powers of the 2 variables. So, here the power of y is 2, the power of x is 1. So, this is 2 plus 1, that is 3 is the degree of this polynomial, children. So please write down. Now let us go to the second problem of this. Do this. What is the second problem? Second problem is coefficient of x square. What is the meaning of this coefficient, children? Coefficient means whatever is the number given to that particular variable which is asked. Here in this problem, the variable that is asked is x square. So in the given expression, first you have to see where is x square. So for that x square, what is the number, constant value that is given? That is considered as coefficient. In case if it has got a minus sign, you will have to take with the minus. If it has got plus sign, you can take the number as it is. So let us see the first one that is given to you. 15 minus 3x plus 2x square. So what is we are going to write? Coefficient of x square. So in this x square is where, children? 2x square here. It is. Where is x square? This is x square. What is the constant term given? 2. So 2 is the coefficient of x square. Now let us see the next one. Pi x square minus 3x plus 5. So in this x square is this. For this coefficient is pi. Pi means you know, no, children. 22/7. And the third one is, second one is 1 minus x square. Sorry, children. Let us see. Second one is 1 minus x square. So in this case, x square has no coefficient given. Don't take it as no, nothing means 0. Nothing means 1 in algebraic expression. So you have got 1 here, children. Now the next one is pi x square minus 3x plus 5. So x square coefficient is pi here. And fourth one, you have got root 2 x square plus 5x minus 1. So coefficient of x square is root 2. So root 2 is your answer. So copy this, children. Now let us see what do you have in the next part of your textbook. You have got in the next part types of polynomials, children. You have got types of polynomials according to degree. According to degree. What are different types of polynomials according to degree? You have got a table in your textbook, children, that has got heading degree of polynomial and name of polynomial and then example. These are given. The first one is given as not defined. Not defined is called zero polynomial. What is this not defined means, children? Means if you have given an example 0, 0 can be having a power of 10, 0 can be having a power of 100. Whatever is the power of 0, you will be getting 0 only. So if you don't have any polynomial, we call that it is not defined. Next, zero polynomial. Degree is 0. Degree is 0 means we call it as constant polynomial. Why will you? Example, if you take here, they have given examples as -12, 5, 3 by 4, etc. They have given. So, how can you say that it is a polynomial? Actually, -12 means -12 x to the power of 0. X to the power of 0 is nothing but 1. That is, you will be getting -12 only. So, only the values are given to you means don't consider that there is no variable. If there is a variable, in case you will be getting some problems where you need to have this idea to solve the problem, where the value of x, the power of x should be 0. Then only you cannot express the variable here. When there is no variable expression given in the given polynomial means what? Whatever is the variable that you are considering, it is having the power as 0. So, 0 is the degree of the polynomial means you will be getting the name of the polynomial is constant polynomial. And if you have degree as 1, this is called as in your textbook, you have got a line like this. It is you have to fill up. This is called as linear polynomial. Examples, what you can take? Examples can be taken as 3. Here they have given examples, they have already given. So let me write here x minus 12 minus 7x plus 8 ax plus b, etc. So what is the meaning of linear polynomial means? Since you have done in your lower classes, the graph values you have done, graph problems you have done. In that graph problems, you will be getting a straight line when you take some value to this x and get a solution. Suppose I have taken x value as 13. 13 minus 1 is 1. So, x value is 13, total value is 1. This becomes an ordered pair. This point you can represent on the graph. Like this, 2-3 points you can take and put them in the graph and join the lines. When you join those lines, you are going to get a straight line. Definitely, you will be getting a straight line. That kind of polynomials are called linear polynomials. Definitely, all linear polynomials will be having degree as 1. Even you can take 4x, single term. Also, you can take children. They have not given, but I am writing. This is also you can take it as an example because when you go for graphs, some lines, suppose this is a graph that you have done. Some lines, when you take the values, you will be getting the lines like this. Some lines you can see passing through the origin. So, all the lines which are passing through the origin are in this form. The lines which are not passing to the origin are the other forms. So, whatever it is, they are giving you the straight lines. So, we call them all as linear polynomials. These all are considered as linear polynomials. And if you have got degree as 2, we call it as quadratic polynomial. So, quadratic polynomial, example you have to write. They have given the dashes here. So, you can write 2x square plus 5x minus 3. This is a quadratic polynomial because you have got the highest power as 2. Now, the third one is cubic polynomial. It is a cubic polynomial. Here they have even given you the example, that is 3x cube minus 2x square plus 5x plus 7. So you can see the highest power is 3. If you have the highest power as 3, you will call it as cubic polynomial. So the types of the polynomials according to degree are these, children. Write down. Next, you have another table given in your textbook. Let us discuss about that also. Now, we have done according to the degrees. Now, types of the polynomials according to number of terms. Number of terms. According to number of terms, what are different polynomials? So, number of non-zero terms. Non-zero terms they have given, and name of the polynomial and example and what all the different terms in it. So first one, number of terms are 1, then we call it as monomial. What is the example given here, children? Minus 3x. Only one term it is. So whatever the terms that you have got, only one term, that is minus 3x. And second one means it is not second one. If number of terms are 2, we call it as binomial. And this binomial example is given as 3x plus 5 by 1 and 2. So what are the terms you are having? 3x and 5 are 2 terms. And if you have 3 terms, we call it as trinomial. And in this trinomial, the value that is given to you is 2x square plus 5x plus 1. So here dash is given to you. You have to write the values. What are the values you have got? You have got one term is 2x square and another term is 5x and another one is 1. Then more than 3. More than 3. It is called as multinomial. Don't call it as a polynomial. Why? I will tell you just now. Multinomial means what I can take any example that they have given you a dash here. So I will take 4x to the power of 5 plus 2x to the power of 4 plus 3x plus 4. How many terms I have got? 1, 2, 3, 4 terms. So if you have, sorry children, they have already given you the example. So let us take that example words. With that you need to do. What is that he has given? 3x cube, 2x square, minus 7x and 5. So with that only we have to do. So you will be writing 3x cube plus 2x square minus 7x plus 5. This is what you need to do it in the blank. So here you have got a note, children. What is the note given, you know? A polynomial may be a multinomial, but a multinomial is not a polynomial. That means I can write all multinomials are not polynomials. Actually, a polynomial is a multinomial, but all multinomials cannot be a polynomial. The reason for it is, suppose if I take same example, if I take 3x cube plus 2 by x square minus 7x plus 5. Definitely we call it as a multinomial because more than 3 terms are there. But you cannot call it as a polynomial. What is the reason, children? You have got x square in the denominator. Since you have got x square in the denominator, we will never call an algebraic expression with a variable in the denominator as a polynomial. So it cannot be a polynomial. What do you understand by this, children? All polynomials are multinomials, but all multinomials are not polynomials. I hope you have understood this, children. And with this, I am going to conclude. Just copy this, children. Now with this, I will conclude my topic. Next one, I will do it in the next.